Okay, all review today. So on this one right here, can somebody remind us what shape does this make? If you had to describe it to somebody, Luke? It's a V shape. Can somebody tell me what does that plus 2 do to the V shape, Si? Moves it left 2. So we've got a graph that looks over here. Remember that V shape is just a perfect 45-degree angle coming in, perfect 45-degree angle going out, unless it's been stretched or shrunk, which this has not. This one right here, Gavin, first rule in factoring? Take out the GCF. And when we take out the GCF, that means take out the GCF along with the leading sign. So we're going to take out a negative 2. That leaves us with a V squared, a negative 11V, and then this is going to be a plus 18. So don't forget the 2 out here. This happens to be an easy trinomial once we pull that 2 out there. We're looking for 2 numbers, Colson, that?
Multiply to be positive 18 combined to be negative.
Perfect. Multiply to be positive 18, combined to be negative 11. Keely, do you know what they are? Negative 9 and negative 2. There we go. You can double check. Do they multiply to be positive 18? Yep. Do they combine? Do they add together to make a negative 11? They do. Okay. So if a quadratic has a perfect square, we can use square roots. Use the square root property to solve those. If it doesn't have a perfect square, then we have to complete the square in order to make a perfect square so we can use that. Now, we've done these techniques before, but on the problems that we do today, it's possible to get both real and, what do you think? Imaginary would be okay, but I kind of covered imaginary over here. We kind of group them into a bigger category. Luke? Complex. Okay. So if we say find the complex solutions, what we're basically saying is we're not limited to just the numbers that we normally get, just real numbers. It's okay to have square roots of negatives now. And we haven't done any like this before. So we're going to do this one by solving each one of these using the square root property. And that's what your assignment is going to be today. And I'm going to wrap up at the end of class with something that I hope you find interesting. We've got a perfect square right there. All we do is we take the square root of both sides. We don't forget the fact that when we put a square root in a problem, what else do we have to put? It's not there. If there's a square root in a problem already, we don't have to put this. But if we put a square root in a problem, we have to acknowledge the fact that, yeah,
Plus or minus.
we have to put a plus or minus. Very good. So this is going to be plus or minus 4i. Done. That's it. It's the square root of negative 16. We pull the I out front, and then we do the square root of 16. The I acknowledges the fact that we're taking the square root of a negative, and then we just figure out whatever that is. If it simplifies like this, then we're in great shape. On this problem right here, we're going to move this to the other side, so we're going to add 9. So 4x squared equals 9. I'm going to keep solving this. Andy, do you know what we're going to do next? There's really 2 options for this. We could take the square root. It might be a little bit easier if we do something else, if we completely isolate that perfect square. Yeah. Sure. If we divide both sides by 4, and this isn't the only way to do it. We could just take the square root as we are right there. This would be x squared equals 9/4. The good thing about this is there's that cool property about quotients, about fractions and radicals. I can take the radical of the top and the radical of the bottom. So I get an x over on this side, and then what do I have to put here, Wilson?
Plus or minus.
Plus or minus. And then there's a 3 on the top because that's the square root of 9, and a 2 on the bottom, and we've got 2 answers right there.
Right.
Okay, any questions? Okay, you can talk to crew about puns later. So we're going to do the same thing here. Again, the best technique is going to be to isolate that perfect square. So I'm going to subtract 13. So this is going to give me, let's see, negative 2, x minus 3 quantity squared equals negative 13. This doesn't mean I'm going to have the square root of a negative because I haven't got that by itself. So I'm going to get rid of the negative 2 by dividing by negative 2. So here's what I've got. I've got x minus 3 quantity squared. This is a 13/2. Not quite as nice as what we had before. Lydia, what do we do next? Take the square root. So we're going to take the square root of both sides. So if I take the square root here and the square root here, I only need a plus or minus on one side. So I'm going to write x minus 3 equals, this is going to be plus or minus radical 13 over radical 2. We don't leave fractions underneath the radical, and we don't leave a radical in the denominator. So can somebody raise their hand and not tell us what to do Tell us what it's called. We'll try that first. Remember what it's called? We just mentioned this yesterday. Mason?
Extrapolate?
Nope.
Or not extrapolate. Well, conjugate.
Crew?
Multiply by a funny looking one.
We are going to multiply it by a funny looking one, but the name I'm looking for? Rationalize the denominator. When we rationalize the denominator, that sounds like a funky explanation, but what it means is make the denominator a nice number. When we say rationalize the denominator, basically we're saying make the denominator a nice number. So I need another radical 2 down there, so I have a pair of 2's. So this is going to be x minus 3 equals plus or minus. This is going to be radical 26 over 2. And then I just move the 3 over there to join those. So here's what I get. I get x equals 3 plus or minus radical 26 over 2. And you can usually just leave your answer like that. If we wanted to break it into 2 pieces, we could. We could do a 3 plus radical 26 over 2 and a 3 minus radical 26 over 2. A lot of times we'll just leave it that way. If we needed to use this in a real world scenario, we'd probably get a decimal for it. Okay? Any questions there? Okay. I want everybody paying really close attention because we're going to do these 3 problems. Then we're going to look at problem 14 on the assignment. We'll do a self-assessment and then I'll turn you loose on the assignment for today. So here's the deal. This says solve each one by completing the square. So watch very carefully. I need to complete the square with the variables on this side. So I'm going to move the 32 to the other side. So I'm going to write x squared plus 12x. I'm going to leave some space for completing the square. And I've got a negative 32 on the other side. This needs to be a 1x squared to make this work. If it's a 1x squared, we're in good shape. Okay, this one happens to be a 1x squared, so we're fine. We're going to take half the middle coefficient. That's a positive 6. I like circling that because I'm going to come back and use it again. I then square that and I add it to both sides. I'm going to change colors here. So I'm going to add, I'm going to add 36 to this side, and I'm going to add 36 to this side. So I wrote it in red because I actually changed the original problem. So this is going to be x plus 6 quantity squared. And over on this side, I've got a negative 32 plus a 36, so I get a 4. And Hannah, what do we get to do now? Yeah, we just get to take the square root. We've turned this into an easy problem like we had up above. So this is going to be x plus 6 plus or minus 2. And I just keep solving. Subtract 6. So I get x equals negative 6 plus or minus 2. Now, there are some people that will stop right here. But when it's something simple like integers like this or nice fractions or something, go ahead and break it into the 2 pieces that we need here. One of them is negative 6 plus 2. The other one is negative 6 minus 2. So here are the 2 answers. We get a negative 4 for an answer, and we also get a negative 8. So those are the 2 answers. And a lot of times people will write them like that. Totally fine if you wrote it like that. If you wrote x equals negative 4 and then write another x equals negative 8, that would be fine too. Okay. Any questions? Okay. I'll give you a head start. Move the 10. Half the middle coefficient. Square that, put that on both sides. Perfect square. We just made a perfect square. That was the whole point of what we were doing. We get a negative 1 over there. I've now got a perfect square with x in it, so I'm going to take the square root of both sides. I'm going to write an x minus 3 over here. What do I write on the other side, Megan? If we
plus or minus.
Plus or minus, definitely. And we said never forget this. If you see a square root of -1, what is it? An I. So this is an I. So if I just move the 3 over by adding 3, I get this. X equals 3 plus or minus I. If you wanted to leave it that way, you could. If you wanted to break it up into two different parts of the answer, we could do this. We could write X equals 3 plus I, and then we could write 3 minus I. So you get those two answers. Okay, now, does anybody notice anything about those? They have a name. Starts with a C. We talked about it yesterday. It's at the top of the page for 5.2. Luke, what is it?
They're conjugates.
They're conjugates, which, if you were listening yesterday, Mason, conjugates is a fancy way of saying what? Factors for a difference of squares. Very good. Now, I need you paying really close attention to this one. This one's going to be different. First thing we're going to do is we're going to clear space to put that constant in there. So we're going to write down 2x squared plus 4x. We're going to move the 5 to the other side, so that's a plus 5. I can't complete the square with this, or at least it's a heck of a lot easier if I don't have that 2 there. So can somebody raise their hand and tell us, how can I get rid of that 2? How can I do a legal algebraic move and get rid of the 2? I want it to be a 1. Crew.
Divide by 2.
Divide by 2. That means we're going to have to divide everything on both sides by 2. So divide by 2, divide by 2, divide by 2. Yes, that introduces a fraction over here, but on this side, at least we get x squared, which is what we want. I have a 2x, which I'm okay with, and I have a 5/2 on this side. Zach, what's the next step?
You divide the middle one by 2.
By 2, or take half the middle coefficient, so that's going to be a 1. I'm going to put a circle around that. I'm going to square it, and I'm going to add it to both sides. We've made ourselves a perfect square, so this is a perfect square of x plus 1 quantity squared. And over here, I've got to get a common denominator, so I'm going to say that's a 2 over 2. So that's going to give me 7 over 2. And then I run into the same type of thing we did a few minutes ago. So Gavin, what do I do next?
You're going to take the square root of both sides.
We're going to take the square root of both sides. Keely, what do I need to write right here?
You need to write negative, or square root of 14 over 2.
I'm okay with that. She's way ahead of me. Square root of 14 over 2. I like that. That wasn't what I'm talking about. I'll show you where she got that if you don't see. I need something else in front, though. Plus or minus. Got to have the plus or minus. Here's how she did that. Square root of 7 over the square root of 2. Realizing we need to, Luke, what's this called again? We need a nice denominator. Denominators are hard enough. Fractions are hard enough without having ugly numbers down there. So this is going to be x equals -1 plus or minus radical 14 over 2. We can write it like that. If you wanted to get really clever, ready, watch. I could get a common denominator with this one, and I could turn this into a 2 over 2, and I can write it like this. -2 plus or minus radical 14 over 2. Either way would be fine. This one's kind of in two separate pieces, two terms. The other way is okay too. You could also break it up and you could write each one completely separately as separate answers. One with a plus and one with a minus, which both would be, if one's got a plus and one's got a minus, they're conjugates. Okay, everybody good? Okay, any questions? Okay, when I give you the assignment, I want you to take a look at number 14. Would you kind of rate how you're feeling about this right now? This should all be review. How many problems?
15.
Only 15? 16? Oh, because of the self-assessment too.
You should let us skip.
That's rough.
You should let us skip.
That's really rough. I'll think about it. Let's
Seven.
take a look at number 14.
Let us get rid of multiples of 17.
Why 7? Use 6.
Yeah, you should do multiples of 6.
Okay, let's take a look at 14.
Yes.
Oh.
Divide by 2.
Oh.
Right?
Ah.
There's not a 0.
Let's just wait a second.
They did the first step.
They did the first step for you. Okay, so Colson, what should we do to kind of clean this up a little bit?
Divide by 4.
Okay, so here's what we're going to do. We're going to do 2 steps at once. We're going to divide by 4, and we're going to create some space. So this is going to be a b squared. This is going to be a 3/2 b, because I'm just going to reduce that. And then over on this side, I'm going to have negative 7/4. Okay, now a lot of people will say the next step is take the middle one and divide by 2. If it's a fraction, dividing a fraction by 2 is kind of tough. It's easier just to say to take half of that. 1/2 times that. 1/2 times that would be 3/4. I'm going to keep this. Gets a little weird here because I'm going to take that, I'm going to square it, right? Because I'm making a perfect square. So this is going to be a 9/16. So I'm going to have to add 9/16 on both sides. Now I'm going to pause right here. We doing okay? Just details to keep track of, right? Might be ugly numbers, but we can deal with that. The reason we kept that hanging around, that 3/4, is so we could write this as b plus 3/4 in parentheses, quantity squared. And then I just need to clean this up right here. Get a common denominator. So that's going to be times by 4 and times by 4. So that's negative 28 plus a 9. I got negative 19/16. You guys okay with that? Okay. Now, there's something cool that happens here. Wilson, what's the next step?
Square it all.
Take the square root of both sides, right? B plus 3/4. That thing that looked really nasty to begin with, think about this. This is a square root of negative 19 over the square root of 16. Holy cow, that bottom's just a 4. We like that. This is a square root of 19. There's 2 things about that. One, it's negative. Pull an I out. And what's cool about 19 if we're talking square roots? Yeah, it's prime. You can't do anything with it. So this is plus or minus I radical 19. Colson, will you grab the door?
Yeah.
Move this to the other side and look what we've got. We've got negative 3/4 plus or minus I radical 19 over 4. What's the cool part that I'm talking about? They already have a common denominator. So if you want to leave it like that, you can. There's no problem with that. If you want to write it as negative 3 plus or minus I radical 19 all over 4, you can write it that way. And if you really wanted to get crazy and show off, you could do this. Negative 3/4 plus I radical 19 over 4 and negative 3/4 minus I radical 19 over 4 and say, hey, look, showed you that I got 2 of these. And what are those? Because one's a plus and one's a minus. Those are complex conjugates. Okay? All right, I'll make you a deal. But first I'm going to stop the recording. No, let me stop the recording first.
So that they don't know what we're doing.